Math Simplified. This video is for 9th standard students. We are studying the 4th chapter Geometry. Topic is quadrilaterals. Exercise is 4.2. Please subscribe and share with your friends also. Quadrilateral. A closed four-sided figure is called a quadrilateral. So these are examples of quadrilaterals. All of them have four sides. Trapezium, parallelogram, rectangle, square, rhombus, kite. Okay, parallelogram. Opposite sides are equal and parallel. Opposite angles are equal. Sum of the adjacent angles is equal to 180. Diagonals bisect each other. So here this is parallelogram. Opposite sides are parallel and equal. So this is equal to this. They are parallel to each other. Okay. So diagonals will bisect each other. Opposite angles are equal. In rhombus, all sides are equal and opposite sides are parallel. Opposite angles are equal and sum of adjacent angles is 180. Diagonals bisect each other at right angles. So here is rhombus. All sides will be equal. Important thing here is that the diagonals will bisect each other at 90 degree. Trapezium, one pair of opposite side is parallel. The angles at the end of non-parallel lines is supplementary. In isosceles trapezium, the non-parallel sides are equal in length and diagonals are equal in length. So here this is an example of trapezium. So there are two sides which are parallel to each other, but they may not be of the same length. The other two sides may be equal or may not be equal. If they are equal, then the diagonals will be equal. Okay. Kite, two pair of adjacent sides are equal. One pair opposite angles are equal. Diagonals intersect at right angle. So here is an example of kite. This adjacent sides are equal. Okay. Important thing is the diagonals will intersect at right angle. So kite and rhombus, the diagonals will intersect at right angle. Okay. Parallelogram. In this exercise, most of the sums will be based on parallelograms. So be careful to learn this quadrilateral very well. It's very simple only. There are 5 theorems in parallelogram, which is proved in your textbook. You can go through those theorems. The first theorem says that the opposite sides are equal in a parallelogram. So these two sides are equal. Second, a diagonal divides the parallelogram into two congruent triangles. So if we take a diagonal like this, then this triangle ADB is congruent to DCB. That's the second theorem. Opposite angles of a parallelogram are equal. So angle D is equal to B and angle A is equal to C. Diagonals bisect each other. So AD will bisect DB will bisect AC. Parallelograms on the same base and between same parallels are equal in area. So supposing there are two lines, parallel lines like this is the base. If we can draw so many parallelograms. This is one parallelogram, this is another, but all these parallelograms with the same base and in between parallels will have the same area. Okay, let's now go to the exercise 4.2. Question 1. The angles of a quadrilateral are in the ratio 2:4:5:7. Find all the angles. So here the angles are given in ratio form. So we can multiply a common factor x variable so that we'll get the angles as 2x, 4x, 5x and 7x. And their sum is always 360. So, okay. So, 2x plus 4x plus 5x plus 7x is equal to 360. 18x is equal to 360. X is equal to 360 upon 18. X is equal to 20. Now, we have to find the angles. So, substitute x as 20 here. The first angle is 40 degree. Put x here as 20. Second angle is 80 degree. Third angle is 100 degree. And the fourth angle is 140 degree. Okay. In a quadrilateral ABCD, angle A is equal to 72 degree. C is supplementary of A. That means what? Supplementary angles we learnt in the first exercise. that their sum will be equal to 180. So if this is 72, then this angle is 180 minus 72. That is 108. Okay. So we found one angle, angle C. Okay. The other two angles are 2x minus 10 and x plus 4. Find the value of x and the measure of the angles. So these two angles we have to find now. Okay, the sum of all the angles is 360. So write down 2x minus 10 plus x plus 4 plus 72 plus 108 is equal to 360. Therefore, simplify it further. You get 3x is equal to 186. X is equal to 62 degree. Okay. Now substitute x is equal to 62 here. Okay, you get 2 into 62 minus 10, that is 114. So this angle is 114. Substitute x here, 62, you get 66. So angle D is 66. Okay. Question 3. ABCD is a rectangle whose diagonals AC and BD intersect at O. If angle OAB is 46 degree, they have given, you have asked to find angle OBC. OBC. So this angle we have to find. Angle OBC. Okay. So this is a rectangle. So in a rectangle, the diagonals are equal and they will bisect each other. That means this OA is equal to OB. That means their opposite angles are equal. So OBA is equal to 46 degree. Okay. Now we know that in a rectangle CBA is equal to 90. Okay. So OBC is equal to 90 minus 46. That is equal to 44. So this angle is equal to 44. Okay. The lengths of the diagonals of a rhombus are 12 centimeter and 16 centimeter. Find the side of the rhombus. Okay. All the sides of the rhombus will be equal. Always remember that. So if we find one side, that is enough. It's the same value for the other sides also. Okay. So this is the rhombus. Okay. These are the diagonals. This AC is 16 centimeter. Therefore, OA is equal to 8. Diagonals bisect each other. Okay. So this will be 8. This BD is equal to 12 centimeter. So what is BO? It is 12 upon 2, that is 6. Okay. Now look, take this triangle ABO. So take this triangle ABO. So this is a right angle triangle. This is 90 degree. They bisect each other at 90 degree. Okay, in a rhombus. So AB square, Pythagoras theorem, AB square is equal to OA square plus OB square. Okay, so that is 8 square plus 6 square. Solve it, you get 100. AB square is equal to 100. So AB is equal to 10. So all the sides are 10 centimeter in this rhombus. Question 5. Show that the bisectors of angles of the parallelogram form a rectangle. So this is the parallelogram ABCD. These are the angle bisectors. That means it will divide this angle A into two equal parts. Okay, that is an angle bisector. They'll meet like this and it will form a quadrilateral. We have to prove that this is a rectangle. To show that this is a rectangle, we have to show that this angles are all 90 degree. Okay. So let's now prove. These are two parallel lines and we know that this angle D plus angle A is equal to 180 degree. Okay. So if we divide both the sides by 2, we get half of angle D plus half of angle A is equal to 90 degree. What is half of angle D? It is this angle ADS. This angle plus DAS is equal to 90 degree. So if you add this angle plus this angle is equal to 90 degree. So what is this angle? DSA. This angle is 180 minus 90. Is it not? So we get 180 minus 90 is 90 degree. Okay. Now this angle is 90 degree. So this angle PSR is vertically opposite to this. So this angle is also 90 degree. So we have proved that this angle is 90 degree. Similarly, we can prove this is 90, this is 90, and this is also 90. So this is a rectangle. Okay, question 6. If a triangle and a parallelogram lie on the same base and between the same parallel, then prove that the area of a triangle is equal to half the area of the parallelogram. So here, these are the two parallel lines. AB is the base. With this base, we are getting another parallelogram like this, DC. Can you see? This is a parallelogram, ABCD. Okay, and we are also getting a triangle. We put a point here and we get AEB triangle. We have to prove that the area of this triangle is equal to half the area of this parallelogram. For that, I am going to draw a perpendicular to the line like this, F. Okay, so what is area of this triangle? Is 1/2 base. Base is AB. Base into height, EF. So 1/2 base into height, EF. What is the area of the parallelogram? That is base into height. So AB into EF. Okay, AB into EF is the area of the parallelogram. So here it is AB into EF. Substitute here area of parallelogram. If you write here, you get area of the triangle ABE is equal to half the area of the parallelogram ABCD. Okay. Question 7. Iron rods ABCDEF are making a design in the bridge as shown in the figure. If A is parallel to B, C is parallel to D, E is parallel to F, find the marked angles. Okay, so here is the diagram. This line is A, this line is B, they are parallel. This line is C, this line is D, that is parallel. Okay, these two lines meet at O. This line is E and this line is F. These two are also parallel lines. Okay, now first question, they are asking us to find angle AOC. AOC, this angle. You can see it is vertically opposite to BOD, which is 30 degree. So this angle AOC is equal to 30 degree. FEC, okay, FEC, this angle they have to find. So here these two are parallel lines and this is the transversal. So this angle plus 75 is equal to 180. So this angle is 180 minus 75, that is 105. Next is EFB. So this angle plus this angle is 180 degree. So this angle is equal to 180 minus 105. So we get the answer as 75. So this angle is 75. Last, they are asking us to find FBA, this angle. So this angle plus this angle is 180. So this angle is equal to 180 minus 75, which is 105. Question 8. In a given figure, angle A is equal to 64, angle ABC is 58, angle AB, so this whole angle is 58. If BO and CO are the bisectors of ABC and ACB respectively of triangle ABC, find X and Y. Okay, so here they have given, this is the triangle ABC. They have given this angle A as 64, this whole angle B as 58. They are asking us to find X and Y. Okay. Now, first let's take this triangle ABC. What is the value of this angle C? It will be 180 minus 64 minus 58. That is, we get 58. So, angle C is also 58. This is also 58. This is also 58. Okay. This is an angle bisector. So, what is this angle OBC? 58 upon 2, 29 degree. OBC is 29 degree. This angle also is, this is also angle bisector, and this angle we found it as 58. So 58 upon 2 is equal to Y, and it is also equal to the angle OCB. This is 29, this is 29. Okay, okay. Now we have to find x. So x plus 29 plus 29 is equal to 180. So what is x? 180 minus 29 minus 29 is equal to 122. Okay. So here the rule is that all the angles of a triangle will be 180 degree. Always remember that. Question 9. In the given figure, if AB is equal to 2, BC is equal to 6, AE is equal to 6, BF is equal to 8, CE is 7, CF is 7, compute the ratio of the area of quadrilateral ABDE to the area of triangle CDF. So here the quadrilateral is ABDE. Can you see this quadrilateral? The area of this quadrilateral to the area of this triangle DCF. That ratio we have to find. Very simple sum. What we are going to do is, first we are going to find the area of this triangle, and we'll say that it is equal to this triangle. Okay, and then we will subtract this common portion. If we do that, we are left with the area of this triangle and the area of this triangle. Okay, very simple. Let me explain again. Okay, consider this triangle ACE. Okay, so here can you see the sides of the triangle? That is 8, 6 and 7. Okay, now here consider this triangle BFC. The sides are again 6, 8 and 7. That means by triple S rule, SSS rule, both the triangles are congruent. That means that their areas are equal. So this triangle ACE, the area is equal to BCF. Okay. Now this area of this triangle is common to both. So I'm going to subtract it from both the sides. Okay. See here, the area of triangle ACE is equal to area of triangle BCF. Subtract triangle BDC on both sides. So what are you left with? You are left with the area of ABDE, which will be equal to the area of FDC, this triangle. Both the areas are equal. So the ratio is 1:1. Okay. Question 10. In the figure, ABCD is a rectangle and EFGH is a parallelogram. So this is a rectangle and this is a parallelogram inside. Using the measurements given in the figure, what is the length D of the segment that is perpendicular to HE and FG? So this D, this line segment is perpendicular to HE and FG. Okay. So first we have to find the area of this rectangle. Okay. So what are the sides of this rectangle? 4 plus 6, 10. 5 plus 3, 8. So 8 into 10, that is 80. That is the area of this rectangle. Okay. Now what we are going to do is, we want to find the area of this parallelogram. Okay. To find that, what I am going to do is, find the area of these triangles. Okay, these 4 triangles, and subtract them from the area of the rectangle. So what we'll be left with? We'll be left with the area of the parallelogram. Okay, let's find out the area of this triangle. It is 1/2 3 into 4. There are 2 triangles, so 2 times I will multiply. Similarly, this triangle is 1/2 6 into 5. There are 2 triangles, so 2 times I'll multiply. So here, the area of this triangle, I'm multiplying 2 times, minus the area of this triangle into 2. Okay, this we are subtracting from 80, the total area of the rectangle. So what we are getting, you simplify it, you will get 38. 38 is the area of the parallelogram. Okay, now we are going to find this D of the parallelogram. Okay, let's find out this side. Now you know this is a right angle triangle, this is the hypotenuse. So the length of this side is square root of 4 square plus 3 square. That is equal to square root of 25, that is 5. Okay. So this is 5. HE is 5. Okay. Now what is the formula for the area of a parallelogram? Base into height. This is the height. So HE into D. HE is 5. Area of the parallelogram, we found out it is 38. So 5 into D is equal to 38. D is equal to 38 upon 5, that is 7.6. Okay. Question 11. In a parallelogram ABCD of the accompanying diagram, line DP is drawn bisecting BC at N and meeting AP extended at P from vertex C. Line CQ is drawn bisecting side AD at N and meeting AB extended at Q. Lines DP and CQ meet at O. Show that the area of the triangle QPO is 9 upon 8 of the area of the parallelogram ABCD. So this is the diagram here. This is the points M and N. Okay, it is a midpoint here, and this also is a midpoint here. Okay, so here we can see that we have this triangle OQP. We have to prove that the area of triangle OQP is equal to 9 upon 8 the area of this parallelogram. Okay, can you see? ABCD. So area of OQP is equal to 9 upon 8 area of ABCD. We are going to prove that. Okay, it's a very simple sum. Just be attentive. It will be easy. Okay. So first what we are going to do is we are going to prove that QA is equal to AB is equal to BP. Okay. All these three line segments are equal. Therefore, QP is equal to 3 times AB. I'm going to write it like that. Okay. So here, how do we prove that? First, we are going to take this triangle QCB and MN is equal to 1/2 QB. Okay. Similarly, if you take this triangle, MN is equal to 1/2 AP. What is AP? AB plus BP. And here QB is QA plus AB. That means if you subtract AB, you find that QA is equal to BP and is also equal to AB. Therefore, we can say QP is equal to 3 times AB. Okay, this is the first statement we got. Okay, now next step what we are going to do is we are going to draw a perpendicular OX to QP like this. Why we are doing it? Because we want to find the area of this triangle QOP. Okay, so what is the area? 1/2 base into height. So 1/2 QP into OX. What is QP? 3AB. We already found it. So area of this triangle is 1/2 QP into OX, 1/2 3AB into OX. Okay. Now OX I am going to write it as OY plus YX. So here it is OY plus YX. I have substituted. And I am going to open this bracket. So this 3 I'll keep it outside. Write within bracket 1/2 AB into OY plus 1/2 AB into YX. Okay. Okay. Now let us see what is this 1/2 AB into OY. Okay. OY and 1/2 AB. AB is equal to MN. Okay. So 1/2 MN into OY is the area of this triangle ONM. Okay. So this is the area of the triangle OMN. Okay. What is 1/2 AB into YX? Okay. Here it is. YX is here. AB 1/2. So this YX is what? The same distance. If you take a perpendicular like this, so this is the height of this triangle. Okay. So 1/2 base into height. So this is the area of this triangle AMB. Okay. So here it is. I've written AMB. Okay. So now 3 into area of OMN plus area of triangle ABM is the area of the triangle OQP, this full triangle. Okay. Now let us try to find out what is this area OMN. You can see it is 1/4 the area of this parallelogram. 1/4. Okay. And 1/4. And this parallelogram is equal to this parallelogram. So it is 1/8 the area of this parallelogram ABCD. So OMN is equal to 1/8 the area of ABCD. Okay. Now let us see this triangle ABM. You can see that it is half the area of this parallelogram. And this parallelogram is equal to this. So it is 1/4 the area of the parallelogram ABCD. So it is 1/4 area of ABCD. You add these two, the LCM is 8 and 1 plus 3, that is 3, and 3/8. 3 into 3 is 9, 9/8, and 9/8 the area of ABCD. Hence proved area of the triangle OQP is equal to 9/8 the area of the parallelogram ABCD. Here we come to the end of the exercise. Please go through the exercise once more, pause the video in each sum and practice them.